In type 2 diabetes, glucose builds up relentlessly in the bloodstream, continuously bouncing off cellular receptors that refuse to let it inside. Standard medical treatments often struggle to correct this gridlock because they tend to act as monotherapies, targeting one isolated failure point in what is actually a widespread systemic breakdown. A disease defined by both severe insulin resistance and progressive organ damage requires interventions that can operate simultaneously across different biological systems. Effectively managing the disease involves repairing a coordinated metabolic network, reaching far beyond the simple manipulation of a single blood metric. This is why modern mycologists and endocrinologists are closely analyzing Ganoderma lucidum, better known as Reishi or Lingzhi. Decades of laboratory study have documented its status as a dense repository of highly active biochemicals. Looking at the physical specimen, a tough, reddish-brown, fan-shaped fungus, it is easy to see how its medicinal history began. But under chemical analysis, the mushroom fractures down into two highly relevant pharmacological categories: complex sugars, known as polysaccharides, and organic acids called triterpenoids. These specific compounds give Ganoderma measurable, clinically verified hypoglycemic properties because they physically intervene at multiple distinct metabolic failure points simultaneously. To understand why its potency necessitates its use as a strict adjunct therapy, we have to map exactly how these compounds alter human biology. The first major intervention occurs immediately during digestion, where the body rapidly breaks down complex carbohydrates into simple, highly absorbable sugars. This rapid dismantling is driven by enzymes known as alpha-glucosidase and alpha-amylase, lining the small intestine wall. Ganoderma's triterpenoids operate as natural inhibitors. They physically lock into the active sites of alpha-glucosidase, abruptly halting the carbohydrate breakdown. Blocking this process forces a heavily regulated trickle of single glucose molecules across the intestinal wall and into the bloodstream, rather than a massive flood. This precise biological action mirrors the mechanics of prescription diabetes medications, like acarbose, utilizing the exact same pharmacological pathways. By artificially slowing digestion directly at the source, the botanical provides a crucial first line of defense against severe post-meal blood sugar spikes. Moving downstream from the gut, the next failure point occurs at the cellular level, where severe insulin resistance blocks energy absorption. This diagram illustrates a cellular mechanism regulated by the enzyme AMPK. It acts as a primary sensor that forces cells to shift their focus from energy storage to active consumption. Ganoderma polysaccharides bind to these cellular structures, triggering the AMPK sensor to enter its active state. Once active, this sensor commands muscle and fat cells to aggressively pull ambient glucose directly into their interiors, bypassing the need for insulin. While the cells are pulling glucose out of the blood, the liver creates another layer of metabolic complexity. In a diabetic state, a process called hepatic gluconeogenesis misfires. The liver inappropriately releases large quantities of stored glucose into the circulatory system, even during fasting periods. The botanical directly suppresses specific enzymes in the liver, like phosphoenolpyruvate carboxykinase, that drive this internal glucose production. This dual action attacks insulin resistance from two directions simultaneously, drastically increasing the rate at which cells consume glucose while entirely shutting off the liver's excess supply. The third major intervention addresses the source of insulin itself, the beta cells located inside the pancreas. Chronic high blood sugar places extreme oxidative stress on internal organs, creating a highly reactive chemical environment that continuously damages tissue. Inside the pancreas, this oxidative bombardment triggers apoptosis, programmed cell death, gradually destroying the body's capacity to manufacture insulin. Ganoderma contains a highly concentrated profile of antioxidants that enter the pancreatic tissue. These compounds actively neutralize the reactive particles, establishing a chemical shield that halts further apoptosis and keeps the remaining beta cells intact. By protecting the pancreas, the botanical preserves the patient's endogenous insulin factory, actively preventing the severe, irreversible stages of diabetic progression. Translating these isolated cellular mechanisms into measurable results in human patients is the critical test of clinical efficacy. The biological mapping we've discussed relies on decades of rigorous mycological extraction and laboratory testing. In human clinical trials, researchers found that positive outcomes depend strictly on using standardized, water-soluble extracts of the mushroom rather than raw, unrefined powders. This chart tracks glycemic response over a 12-week period, showing a consistent reduction in fasting blood sugar for extract users. More importantly, data at the 12-week mark reveals a significant, sustained decrease in HbA1c, the clinical marker for 3-month average blood sugar control. Secondary clinical data points to distinct organ protection, noting a reduction in urinary protein excretion that shields the kidneys from diabetic nephropathy. The theoretical models of gut enzyme inhibition and cellular AMPK activation accurately predict measurable clinical glycemic control in human populations. Because this extract genuinely manipulates human biology, it carries severe inherent pharmacological risks. The primary danger of an effective adjunct therapy is the additive effect it has on existing prescriptions. Standard allopathic tools, from oral medications to direct insulin injections, are precisely calibrated to lower blood sugar on their own. Combining a biologically active botanical with medications like metformin or insulin stacks their mechanisms on top of each other, dramatically increasing the risk of a dangerous hypoglycemic crash. Secondary contraindications are also critical. The mushroom inhibits platelet aggregation, meaning patients taking blood thinners like warfarin face a much higher risk of internal bleeding. Furthermore, while refined water extracts show long-term safety, consuming unrefined, raw mushroom powders has been linked to rare but serious cases of hepatic toxicity. Finally, its potent immune-stimulating properties make it strictly contraindicated for autoimmune diabetes profiles or anyone on immunosuppressant therapies. Ganoderma provides a mechanistically sound, multi-targeted metabolic intervention. Its sheer biological potency proves that botanical adjuncts demand the exact same endocrinological respect and precise monitoring as any conventional prescription.